Hello, everybody. I'm Nasmus, and I'm going to do the demo part of this presentation. So over here, I have some information ready, which I'm going to present right now. So for this project, our presentation part is going to be on running the LSTM machine learning algorithm on uh, to classify texts, basically. So further explaining, I'm just going to start with what we are going to do. So as you can see over here, we have a data set which has basically 550,000 uh, IMDb reviews, which has which has like basically positive and negative sentiments assigned to them already. So we are going to use the LSTM algorithm, which stands for long short term memory. And we're going to use this algorithm to classify texts and so that the program can basically um, explain, the program can basically detect which review is positive or negative after training. So just some of the core concepts that we're going to use before I start with the code. I have to explain word embedding. So what is word embedding? Word embedding is like representing each word in an n-dimensional vector. So suppose we have like man, woman, king, and queen. These are all words, but these words are going to have characteristics like living being, human, feline, gender, royalty, different characteristics. And we are going to assign a positive or negative uh, uh, value depending on how close the characteristics are for that particular word. So this is the text to numeric representation, and it's a semantic relation that retains. It's basically a way of representing words that uh, retains the semantic relationship between the words. So every word has like n-dimensional parameters, and then when we have all these words embedded, we can cluster them, and this is what the clustering looks like. So basically, the cities will have similar characteristics; they'll be clustered in one bundle, and so similarly the other words. So basically, if you have a new word which is very close to, let's say, like this cluster, then we can automatically say that your word is related to travels. So that is the beauty of word embedding. Uh, some of the technologies that basically allow for this to happen are like Glove, which is a library, and also Word2Vec. We're going to use Glove in our presentation shortly. Okay, so now what are we going to use as our machine learning algorithm? We're going to use LSTM, which is long short-term memory. We're also going to use like CNN, convoluted neural network, and also we're going to use a normal neural network, but I'm just mentioning LSTM because this is the algorithm that's going to give us the best uh, the best accuracy. So as you can see, you pass the data set in this neural network input, and we have a hidden layer, which are neurons, which do some kind of processing and return output for us. So this is a chart over here which shows the kinds of neural networks that we have. We have like different combinations of inner neurons and outer neurons, which can give us different neural networks. But in this demonstration, we're going to use LSTM, which is this one in the middle. So it's a variant of RNN, recurrent neural networks. And what's special about this neural network is that it can, just like when, our human minds, like when we're reading a story, we have long-term memory, short-term memory, and then when the story, when a chapter of the story finishes, we can forget something from the last chapter, and then we can like save new inputs in the new chapter. And then it's like, suppose we need in the next chapter we need something from the previous chapter, we can also retrieve that from our long-term memory, the important stuff. We can forget some and we can keep some. Just like that, this is how the LSTM algorithm works. And as you can see over here, there are many gates inside one of these nodes, and each nodes have obviously a lot of mathematics going into it, so that they can process the data the way we want it, like with long-term, short-term, forgetting, saving, and retrieval. All these functions are represented inside the node as these gates. So, so basically, this is an example of how the machine is going to, the program is going to return the output. So iPhone is insane. It's the best thing money could buy. So insane, best thing. It's a positive sentiment. Then service cost, Android, phone is good, positive sentiment. And then it's like, it also understands sarcasm. So suppose someone says like, I would have to sell both my kidneys uh, to get I'm happy with my Android. I'd rather not have an iPhone. It understands the sarcasm and it will report it as negative. So let's get started. So basically, in our methodology, what we're going to use is we're going to use three different machine learning algorithms, like simple neural network, CNN, convoluted neural network, and long short-term memory. So our methodology would be, we're going to get the data set, we're going to remove numbers, punctuation marks, and we're going to take other precautions to clean the data in the data processing step. And then we're going to word embed using Glove, which is going to turn the movie reviews from text to numeric form. And then we're going to train multiple neural networks on this data, which will give us a program that can basically make live predictions on queries about movies. Okay, so once again, this is the data set. We can see that we don't have a skewed data set. We have a pretty even number of positives and negatives. So basically, let's start with the code, and I'm going to explain how we are going to get started with the data processing. Okay, so as you can see, this is the plan of action, which is already I discussed right now. So we're going to start. Okay, before I start, I just wanted to show that this is the data set we're getting the data from. It's called IMDb dataset for 50K movie reviews. And it can be found in this link at kaggle.com. Okay, so before I get started, I have to import all these libraries. As you can see, I'm going to import this library. So we're importing pandas, numpy, regex. We're embedding NLTK, and we're getting stop words from there. And we're using Keras. And we have basically the LSTM algorithm, and we're going to use also going to come from the Keras. And from skitlearn, we're getting train test split, which we're going to use to split the data into training and testing sets. Okay. So now I'm going to load up the data set, which I have over here saved in my folder. So once it does that, we're going to see the shape of the data set. As you can see over here, we have 50,000 rows and 2 columns. So the movie reviews dot head. So we're going to see the first 5 basically rows, and you can see that over here we have data with like sentiments, and over here we have basically all this data which is like not processed yet. So that's why we have like this PR tags and everything, which we'll eventually remove. So now we're going to check for if there is any missing values, any null values in our data set. So that's a good practice when you're cleaning data. So we have no data null values. We're going to use Seaborn to basically plot a chart which shows the sentiment and the movie reviews. So over here, as you can see, we have like in the X row, from the X row, we have the amount of positives and amount of negatives. We're showing the amount of positives and negatives, which are pretty equal, which is needed for a well-balanced data set. Okay, so now we're going to see the review number 2 from our reviews column. And as you can see, it's a long review. And as you can see over here, we have PR tags. Over here, we have some stuff we don't really want in this kind of data when we are like feeding it to a machine algorithm. So we're going to remove a lot of these like PR tags, empty spaces, stop words, etc. And how we're going to do it, we're going to use a regex. First over here, as you can see, we're going to remove opening and closing brackets over here, and we're going to replace them with empty spaces. Once that we're done, we're going to get the stop words library from NLTK, and we're going to have a function which basically removes the HTML tags using our previously made function over here. And then we have like we have some regex to basically remove punctuations and numbers. We have character removals basically So these are basically single character removals and white space removals, which were the byproducts of some of the functions that we already ran before. So we want to remove those too. And then we want to remove multiple spaces in characters. Suppose like we have multiple gaps, multiple spaces after some words, we want to remove that too. And then at the end, we want to use like, basically we want to remove those stop words. So after we remove the stop words and everything, we have like a relatively clean data. So this function basically applies this function to all of the rows in our data set. So that's why it's taking some time, because it's going through all the rows in our data sets and it's going to apply this function, which cleans the data. Okay, once that is done, we're going to see the row number 2, and as you can see over here, the data is relatively clean. It doesn't have any brackets, it doesn't have any weird punctuation marks, or it also doesn't have any stop words. So we can use this data basically. So now we are going to basically if we take the sentiment row of our data, and we're going to turn the positive and negative words into zeros and ones, because that's what we need for our to feed it into our machine learning algorithm. So now we have a situation where we have like the X array, which has like all the reviews, and then Y array, which has all the sentiments, positive or negatives, turned into zeros and ones. At the end, we want to split X and Y into 80-20 ratio, where the 80 is for test, the 80 is for training, and the 20 is for testing. Okay, so now that we have our training set and testing set separated, the next part of our methodology is to prepare embedding layer. So in this step, what we want to do is we want to basically tokenize our training set and test set. So we're going to import tokenizer from Keras preprocessing text module, and then we're going to use it in our train and test set. What this is going to do is this is basically going to turn our training and test set into indexes. So the word in our training and test, the words in our training and test set are basically going to be turned into unique indexes. So each unique word will be represented by a unique number. And then what we're going to do is, before that, if we check the length of our word tokenizer, we can see that is 92,394. That means we have 92,394 unique words in our corpus. Okay, after that, we're going to basically reduce the length of each review to 100 words. This is necessary because we don't want to overflow our data. We want to keep it in a specific limit so that it's easy for our machine learning models to compute. Okay, and then what we want to do is we want to use Glove embedding and create embedding dictionaries. So what's the meaning of this? The meaning is that we have a text file from which has like Glove words and word vectors already, and we want to basically use that Glove file to create our embedding matrix. Okay, so as over here we can see we have a Glove file over here. We have basically words with vectors, with their vectors related to it. We're going to use that to turn so it's going to basically turn, so these are like the kind of, see, for the, we have a bunch of features. For another word like in, like was, we have a bunch of features. We're going to use that as reference, and we're going to turn the words in our corpus to in the same format. We're going to get word vectors for them. And after that, we can see that for our 92,342 words in our corpus, we have 100 columns with different features generated. So this is called our embedding matrix, which we are going to feed into our simple neural network. So in this experiment, basically we're going to use different neural networks and see what combination works for us the best. So in this experiment, we have used 3 neural networks. The first one is called the simple neural network. So we have used, basically we are creating a sequential model, and then we are creating an embedding layer where we are passing our own embedding matrix as the weight, and we can see that the input is 100 and the input length is 100 and the output length is also 100. And once that happens, we're going to add our embedding layer as to connect to our dense layer. We're going to flatten the embedding layer, and then we are going to create a dense layer with an sigmoid activation function. Once that is done, we're going to compile, and we have a simple neural network now, which is ready for training and testing. So we're going to train it using our trained data, and once we trained it, we can see that we got an accuracy of 84.09%. Now we're going to evaluate our train set using the same model, which will give us a test score of 0.94. Because the difference between the test accuracy of our training set and testing set is so high, as you can see in the graphs over here, which compares the accuracy of the training set and the testing set as the epoch gets larger and larger. You can see there's a huge gap. This means that our model is overfitting on the training on our training data, which is not good. So the next step we're going to do is we're going to use a convolutional neural network to basically try the same experiment. So from Keras, we're going to import a convolutional 1D network. We're going to use basically the same process to add the embedded matrix to our CNN. Once that happens, we're going to similarly compile the model, and then we're going to train our model using the CNN. And as you can see over here, we have an accuracy of 95.32%. The same thing, if we basically evaluate our test set using this CNN model, we basically get a test set of 0.85, which is far better than what we got using this the simple neural network. But in this method, the difference between the accuracy of the training set and the test set is still very high, which means that our model is still overfitting in our training data. As you can see in this chart over here, the difference between the train set, the accuracy of the train set and the test set is still very high. So the next experiment we're going to do is we're going to run the same process using LSTM, which is a variant of a recurrent neural network. So similarly, we are basically adding our embedding layer, and we're using an LSTM with 182 neurons. So once we compile this and we fit it in our training data, we can see that we get an accuracy of 86.73%. And when we evaluate the model using our testing data, we get an accuracy of 84.49%, which is very close to 86%. And as you can see, when we plot the accuracy versus epoch of the training and testing set, the difference is very low. That means our model is not overfitting, and this is acceptable. So we can conclude using these experiments that an RNN-based LSTM is the best way to configure a neural network for our problem over here, for our data set over here, to evaluate the sentiment of movie reviews. So just to make a little bit of prediction using our model, so I have like over here some data over here, which is basically which has 6 rows, and it has basically a couple of reviews with no sentiments. So now if we load this up in as sample reviews, and then we run the same pre-processing and the tokenizing steps along with the embedding steps, and we basically use feed this data, and we let our LSTM model predict it. It's going to predict something like this, and which we can see over here. The predicted sentiments are 8.88. So if we compare it to our data over here, side by side, so when someone says it's an intelligent movie, we have like basically a sentiment of 8.8. Similarly, when someone says it's an extraordinary and thought-provoking movie, the predicted sentiment is 9.9. And if we have like someone who is saying that it's the worst MCU film ever, then we can see that it gives the predicted sentiment gives a very low score, which means that the sentiment is not so positive about this movie. So as you can see, from a range of 0 to 10, our LSTM model can pretty accurately give us a prediction about movie reviews. Thank you very much.